What up, geometry students? We are talking about coordinate geometry. We are not placing segments just in space or angles in space. We are going to provide a little more context by using a coordinate plane, which allows us to easily calculate or look at horizontal lengths and vertical lengths. Every time we go over one to the right, we are like adding one to the x distance or the horizontal length, and up one with the y distance. We like to put points not just willy-nilly on a piece of paper. Rather, we will take a point like negative 5, 2, and we will say we are going to be to the left 5 of the origin, and we're going to be up 2 from the origin. So the location of point A, negative 5, 2, has this very specific location. The point B is located at negative 5, 5. Okay, so negative 5, 5 will be left 5 from the origin and up 5 from the origin. Looking at both of those at the same time, we have this segment AB. And we can see, or knowing that the points are at negative 5, 2 and negative 5, 5, we see that from 2 to 5, this vertical length of 3 is visible either on the grid or by looking at the change between 2 and 5 being a plus 3. So I can calculate that length of AB to be 3 just by looking at those y coordinates change or using the grid to help me. If I have the point C at 4, 3, means I'm going to be 4 units to the right of the origin and 3 units up. And here's point C, which is at 4, 3. And then the point negative 2, 3, D. If I connect C and D, I create this line segment CD. And using these positions, either using the grid or looking at the change between negative 2 and 4, we calculate that the length of CD is 6. Either going from negative 2 to negative 1 to 0, 1, 2, 3, 4, or saying from 4 to negative 2, either it's a minus 6 or negative 2 to 4 is a plus 6. We like to call distances and lengths always positive. However, we will start talking about change. Because once you go on a diagonal, the diagonal length is harder to calculate. It's hard to calculate on a coordinate plane. So we're going to take the point EF, which is negative 6, negative 4. That's E. So left 6 of the origin, down 4 of the origin. And negative 4, 0 is F. And I connect these 2 points with this diagonal line. It is not obvious what the length of that diagonal line is. Once I put any diagonal in the coordinate plane, we cannot visually see the length in terms of the grid. But what we can do is split this diagonal into 2 different distances, or 2 different lengths. A horizontal distance and a vertical distance. Now, 2 ways this can be done, either using the grid and seeing that we are going to the right 2 from negative 6 to negative 4, or using the numbers and using the points and knowing that our x starts at negative 6, it goes to negative 4, that's a plus 2 on the x distance. So I would label the horizontal distance as 2. Meanwhile, the y distance goes from negative 4 to 0. So negative 4 to 0, either using the grid or using the numbers, we can see that we are adding 4 to the y's. The vertical distance, therefore, is 4. Now, what we call the combination of these 2 numbers in terms of y's and x's occurring at the same time is a slope. Now the slope of this line segment is the y change divided by the x change. Many of you like to use the slope formula. I don't love using the slope formula. I'd rather understand the change, that my y's went from -4 to 0. So I have a +4. And my x's from -6 to -4. It's a +2. And I then divide those two numbers together and simplify, and I get the slope is 2. Now, slope is just a combination of my y's and my x's. And when you divide them, you have now a y's per x. We would say that from E to F, you can go up 2 y's per 1x, up 2 y's per over 1x, up 2 y's per over 1x. GH is 2, 3, 4, -1. So 2, 3 is G. So right 2 from the origin, up 3 from the origin, H4, -1. So creating the line segment that is diagonal. Splitting it into a vertical distance and a horizontal distance, but then also thinking about the change. I would say that for G to go from 2 to 4, so the x coordinate of G to the x coordinate of H, going from 2 to 4, that x distance is a +2. So using the grid, you can see that 2 units, the 2 boxes. Now, careful for the y's. I'm taking a y coordinate of G at 3 to a y coordinate of H at -1, and I would say that I would subtract 4. 3 to -1 is -4. Now, you could do this using a y2 minus a y1, and you would get -1 minus 3, and that's fine, but I like to just find the change. Now, what we're going to say for the horizontal distance, the +2 stays a +2, but I'm going to say that the vertical distance is 4, like that length is 4. I'm going to keep the -4 in my brain because we are going to use that for slope. It's not distance over distance, rather it's change over change, and I will have -4 divided by 2, or -2 y's per x. That means my y's are going to decrease by 2. So I'm going to go down 2 y's as I go over to the right, 1x. Okay? JK. I'm not even going to graph JK. I'm just going to use the values of J and K. J has x value of 3. K has an x value of 6, which means the x distance between those 2 points is 3. So I'm just going to go +3. If you want to, you could do 6 minus 3, x2 minus an x1. My y's from 4 to 3, I know that's -1. Okay, well, if you wanted to, you could do 3 minus 4. Whatever you want to do works as long as you do it well. In my experience, students don't use the slope formula very well. Subtracting negatives causes mistakes to occur. Now, that's me calculating the slope, where we have our y change of -1, my x change of +3, and I will say that my slope is -1/3. I will say my horizontal distance, and this is without plotting, is +3, and my vertical distance, without plotting, is +1. Okay, the next question just doesn't give you any information about the points. They're just placed on the grid. So you will have to make sure you correctly find the locations in terms of the x's and y's, and then correctly find the slopes. So the first slope is BH, so I need to find the points of B and H. I can see B is 4 to the left of the origin and 2 above the origin, so that's -4, 2. And H is just 2 above the origin and not left or right of the origin, so it's going to be 0, 2. I can see that the y change is plus 0 versus the x change is plus 4. Well, 0 divided by 4 is 0. We will call that slope 0. I'm not going up or down any y's per x. D is located 2 to the left of the origin and not up or down. So I would say D is located at negative 2, 0. E is 1 to the right of the origin and 5 below. So that's a location of 1, negative 5. I can see from negative 2 to 1, that is adding 3. And from 0 to negative 5, that's subtracting 5. Slope is our y's per x's, and I get negative 5/3. Down 5/3 of a y per x. Many of you will say it's down 5 y's over 3 x's. That's also correct. I like to say down 1 2/3 y per x. Okay, we already have point B is at negative 4, 2. Point C is 5 to the right of the origin and 5 above the origin, so that's at 5, 5. I can see from negative 4 to 5, that is a plus 9 for my x's, and from 2 to 5, that's a plus 3. Now, 3 divided by 9, y's per x, could be simplified to be 1/3. We're going up 1/3 of a y per x. HE. H is 0, 2. E is 1, negative 5. I can see that my x change from 0 to 1 is 1. I can see my y change from 2 to negative 5 is minus 7. Let's say you don't know how to do that. If you wanted to, you could do a y2 minus a y1 and understand that minus 5 minus 2 is minus 7. I prefer to just say from 2 to negative 5, I'm subtracting 7. So I have a y change of minus 7. I have an x change of 1. So I say that line segment decreases 7 y's per 1x. I already did DE, so maybe I'm just keeping you honest there. DE slope is negative 5/3. Don't know why I asked you for the same thing. Probably should have asked you for EG, but I didn't. HG. Okay, G is a new point. G is right 7 of the origin. It is not up or down at all, so the location would be 7, 0. That is a possum out in the middle of the field, just eating. Is that a raccoon or a possum? That's a raccoon.
I think it is.
That's scary.
You used to come out during the day.
Exactly. Should we call maintenance?
Yeah.
It could be rabbit.
Let me put in
It's right behind the chapel. I gotta keep my head on a swivel here. We have a rogue raccoon out in the middle of the day here on campus. Behind the chapel. There's nobody around. If it starts coming here, I'm bolting. It is walking this way. It is starting to walk this way, and I'm intimidated. He's running towards me. He is literally running to. Okay, he went into the hole. He went into a hole. He went into the drain hole. Okay, we're safe. He literally started running. All right. Where were we? HG. Okay, well, I can see that my x's go from 0 to 7. My y's go from 2 to 0. So my y's decrease by 2, but my x's increase by 7. I would say that HG's line segment goes down 2/7 of a y per x. Cool. What is the horizontal distance between the 2 points B and C? B has a location of negative 4, 2. C has a location of 5, 5. So from negative 4 to 5, that is a plus 9 x length. From 2 to 5, that is a plus 3. We'll say that things are just always positive. Between H and G, I'm going from 2 to 0 for my y's. I'm going from 0 to 7 for my x's. So I'd say from 0 to 7, that's my horizontal distance of 7. You could see with the in the grid if you'd like to. count over 7 blocks. And I would say that the vertical distance is not -2. I'd say it's rather positive 2. Called distances and lengths always positive. Slopes could be positive or negative. Cool. Next prompt is create a square that contains the 2 points shown and 2 points you choose. Okay, so I have a point at -3, 5. So 3 to the left of the origin, 5 above the origin. And I have a point -3, -2. So I can see that the x change is 0, -3 to -3, but the y change is from -2 to 5 or 5 to -2, and that's a total of 7. If you'd like to do y2 minus y1, you could do 5 minus -2 to get 7. Great. Well, I would like to create a square, and I know squares all have the same length. So I will go either to the right or to the left of -3, -2, and in the same direction of -3, 5, 7 units. Now, where does that take me? Well, I can see that it's an x distance. Well, -3 plus 7 is a quick and easy calculation to do. I'm sure you're probably counting over, if you'd like to, on the grid, just feeling your way over from -3, -2 to the right 7. But it's easy enough to just say -3 plus 7 gets us to 4. So now I have 4 -2 has a horizontal distance of 7 away from -3, -2. And we would be able to do the same thing from -3, 5, just do a horizontal distance of 7. Or if we wanted to, we could do a vertical distance from 4, -2 up 7 and realize that this point will be 4, 5. And all of these points really work in harmony with each other. If you'd like to start at the point, say 4, 5, subtract 7 from the y, we get to 4, -2. Subtract 7 from the x, we get to -3, -2. Add 7 to the y, we get -3, 5. Works out well. Could you choose 2 other points to make the square? Yes. And it's your responsibility to do and find those points without having the grid to help you. How could you maybe go to the left 7, to the left 7 from -3, 5, and from -3, -2? And hopefully you are arriving at the points -10, -2, and -10, 5. Those will both be 7 to the left of -3, 5 and -3, -2. Now, we talk about slopes of parallel and perpendicular lines from class. And we realize that parallel lines will be the same slope as other parallel lines. Like parallel lines will have the same slope. They'll be going in the same direction, the same y's per x. Perpendicular lines have opposite reciprocal slopes. It ends up being this like symmetry of like, if you go up 4, right 3, well then you will go left 4, up 3 to kind of go at a 90-degree angle. So opposite reciprocal slopes. I'm just writing down right now, parallel lines equal slopes. Perpendicular lines, opposite reciprocal. So flipped and opposite slopes. I have the points -1, 4 and the point 1, 1. So I connect these 2 points with a diagonal line. I can see that I'm going to the right 2 and down 3. So -1 to 1, that is a x change of 2. And 4 to 1 is a y change of -3. Great. Now, if I wanted to go at a perpendicular angle from this, I would understand that the slope of this line segment is -3 over 2. the slope of a perpendicular line would be plus 2 over the y's and plus 3 over the x's. Now, that means I could also consider this to be down 2 on the y's and left 3 on the x's. And that's kind of the trick to this problem is you could either go from the point 1, 1 up 2 to the right 3, or you could have also gone down 2 and left 3. They both will give you the same opposite reciprocal slope. So one option, going up 2 to the right 3, gets you to the point 3 on your y coordinate and 4 on the x coordinate. We could have done the same thing at negative 1, 4. We could have gone up 2 to the right 3 and gotten to the point up 2 from negative 1, 4 would have been a y coordinate of 6. Right 3 from negative 1 would have been an x coordinate of 2. And now we have the point 2, 6 and 4, 3, two new points. And I'm going to just make sure things are aligned. The slope between 2, 6 and 4, 3 should be down 3. Okay, 6 to 3 is down 3. Right 2, 2 to 4 is plus 2. That works out. These slopes from negative 1, 4 to 2, 6 should be the slope, same as the slope 1, 1 to 4, 3. Negative 1, 4 to 2, 6 is to the right 3, so negative 1 to 2 is plus 3. 4 to 6 is plus 2, so let's do the y's over the x's. That's 2/3. And the slope 1, 1 to 4, 3 should be 2/3, and it is. 1 to 3 is plus 2, and 1 to 4 is plus 3. Now you could have also gone in the other direction, and I'll do this in a different color. From negative 1, 4, we could have gone down 2 y's and left 3. Negatives over negatives are positives. So if you have a positive 2/3 slope, that is the same as negative 2, negative third slopes. Are you looking for the raccoon? Is he looking for it? Did you send it in?
Yeah.
You're probably. Hold on, raccoon. He was like,
No, I went down to the refuse. It was right into the drain over there.
Yeah.
Cool.
Yeah. Thanks. He wasn't here for it.
no. He's like, I don't know about that. All right, so down to left 3, that would take the 4 from, take the y coordinate from 4 to 2, take the x coordinate from negative 1 to negative 4. Sorry. Yeah, so I should have gone for another. So left 3, negative 1 minus 3 is minus 4. 4 to 2. Just double checking, negative 4, 2 to negative 1, 4. That's a plus 2. That's a plus 3. That's good. And we can actually go off this point, negative 4, 2, and use the same slope as our original line segment, negative 1, 4 and 1, 1. I could go down 3 to the right 2. So 2 to negative 1 is the y coordinate change if I'm going down 3 from 2. If I'm going to the right 2 from negative 4, I would get to an x coordinate of negative 2. So negative 4, 2 to negative 2, negative 1, and there is another square. So I'm going to write down square 1. Could have the points 2, 6 and 4, 3. I could write that square 2 could have the points -4, 2, and -2, -1. That would connect with the points -1, 4. Okay, a couple more questions. Little challenging prompts. We'll see if they're challenging. We have point A at -1, 1. We have point B at 3, 3. So 3 to the right and 3 up. Create point C by continuing with the slope of AB. Would point B be considered on the line segment AC? Oh, what would point B be considered on the line segment AC? All right, cool. So we can see from the x-coordinate of -1 on A to the x-coordinate of 3 on B, that is a +4 x change. And then from the x-coordinate of 1, the y-coordinate of 1 to the y-coordinate of 3, that is a +2 change. So that would be a slope of 2/4 or 1/2. I probably wanted this to be different. If I continued with the same change of this +4 for the x's and +2 for the y's, I would arrive at the point 7 +4 to the x's and +2 to the y's, 5. And that would create this segment AC. Did you have to do that? Like, are you sure you had to do that? This is a lead into the next lesson. Well, we could have also just gone add 1 to the y's and add 2 to the x's to get to the point 5, 4. Now, why didn't I do that? Well, because if we go and continue the exact change of this +4 for x's, +2 for y's, we arrive at the situation where point B would be the midpoint. That is if point C is at the location of 7, 5. Point B is not the midpoint if you arrived at a different location. Could you have arrived at a different location? Sure. If my slope is 2/4, that's the same as 1/2. That's either like 1/2 of a y per x or 1 y per 2 x's. You could have gone to any other point. So here's another example. 2 for the x's makes that a 5, and 1 for the y makes it a 4. So 5, 4. Create point D so that angle ABD is 90 degrees. Okay. ABD. Well, I can go right 4, up 2. I can go down 4, right 2. Down 1, 2, 3, 4, right 2 from point B. And this creates a perpendicular slope. Opposite reciprocals, it's like a symmetry situation. So if I go 3, 3 and I go down 4, that'll take me to a y-coordinate of -1. If I go to the right 2, that would have been a x-coordinate of 5. Conversely, we could have gone up 4, left 2. And if I go up 4, that's a y-coordinate of 7. Left 2 would be a y-coordinate of 1. So here are possible places for angle ABD for point D. You could have 5, -1, or you could have 1, 7. Create a line segment PL that is parallel to and has the same length as AB, but uses the point -4, 2, P. So P left 4, down 2. I want it to be parallel, which means the slope is going to be the same, which means the y change and the x change will be the exact same. So I will be going to the right 4 and up 2. Well, if I go from -4 to the right 4, I'm adding 4, I get to 0. If I go up 2, I will get to 4. So right 4 gets to x-coordinate of 0. up to, we'll get to a y coordinate of 4. How do I know it's going to be the same diagonal distance? It's like it's got the same x change, it's got the same y change, it's got the same x distance, it's got the same y distance. So segment PL as P at negative 4, 2, and L 0, 4. Create a perpendicular line segment RM that is half the length of AB and uses the point 2, negative 1. So 2, negative 1. How can I create half the length? Well, if we are assuming that we can simplify this slope and say the slope of AB is 2/4, that's equivalent to 1/2. Well, I would say that this length of 2 and 4, if I have those lengths, I would think about a length of 1 and 2. Well, if I want a perpendicular line segment, my slope would start out as negative 4 over 2, or down 4 with my y's, right 2 with my x's, which could be halved to be negative 2 over 1, down 2 with my y's, right 1 with my x's. If I'm starting at the point 2, negative 1, I could apply this halved slope, the simplified slope, go down 2 with my y's to get to a y coordinate of negative 3, and right 1 with my x's to get to an x coordinate of 3. I arrive at the point 3, negative 3, and this would be the location of point R. This would be half the length of AB and perpendicular to AB. You could have also gone the opposite direction of left 1 up 2. So we would have gotten to 1, 1 as another location of R. Okay, so starting off pretty simple. You might think you know what you're doing. Just don't make mistakes. Understand perpendicular slopes. Just symmetry, but like opposite y and x change. You don't have to use the slope formula if you don't want to. And we will dive more into slopes, and we'll get into lines next class. Peace.